Welcome to the deep dive. Our mission today to get you up to speed on, well, probably the single biggest structural challenge facing generative AI right now. We're talking about model collapse. We're going deep into the sources on this kind of recursive problem. It's moving fast from just theory to something quite real.
It really is the core dilemma. Simply put, model collapse is what happens when these machine learning models degrade over time.
Yeah.
It's because they end up being trained on their own outputs, you know? What we call synthetic data, stuff the AI itself made.
Synthetic data, right? Not the original human stuff.
Exactly. And the names researchers use for this are quite vivid, actually. Things like AI inbreeding, AI cannibalism, even model autophagy disorder.
Wow, yeah, autophagy, like self-eating, those terms definitely capture it. This idea that the models start to, well, fundamentally misunderstand reality, but why does this happen? Is it really unavoidable, mathematically speaking?
It seems to be baked into the process, unfortunately. You see, any AI model is really just an approximation of the real-world data it learned from. It's not perfect. So when you start training new models on data generated by that imperfect approximation, the errors just compound. They build up. It's inherent because the model is always trying to, let's say, functionally approximate the data distribution. It leads to a kind of signal loss, generation after generation.
Okay, right. Signal loss.
Yeah.
So let's look at the stages researchers talk about, because you mentioned it's kind of sneaky how this degradation happens. There's this early model collapse. What does that actually look like?
Yeah, the early stage is the tricky one. The model starts losing information, but it's mainly from the edges, the tails of the distribution.
The rare stuff, the outliers.
Exactly. Rare facts, unusual scenarios, nuance.
Yeah.
And here's the paradox. Overall performance, like on common tasks, might actually seem to get better for a bit.
Really? How?
Well, because the model gets better at predicting the average, the most frequent things, it focuses on the mainstream. So it's harder to even notice that it's losing its grasp on subtlety, on the edges.
Okay, that is sneaky. So you might not even know it's happening until you keep feeding it this synthetic data, this sort of AI slop, and then you hit late model collapse.
Precisely. And that's when the degradation becomes really obvious. The model suffers a significant loss of variance. It starts confusing different concepts. Mathematically, it kind of collapses towards just predicting the average outcome. Almost all the diversity is gone. It converges towards a single point, effectively.
Wow. Okay, so if this is sort of baked into the math, how is it showing up in the big AI tools we all use now, like large language models?
Well, the research is becoming quite clear on this. When you train LLMs on text generated by older LLMs, you see a consistent, measurable drop in diversity.
Diversity, you mean like vocabulary, sentence structure?
All of the above. Lexical diversity, so fewer unique words. Syntactic diversity, simpler sentences. And semantic diversity, meaning fewer distinct ideas or concepts. The language just gets, well, repetitive, predictable, kind of bland, frankly. And this really hits tasks that need creativity or originality.
Right.
The output can become nonsensical or just incredibly dull.
This really brings us to the big debate, doesn't it? Is this whole model collapse thing inevitable? Because you see some researchers sounding a major alarm saying, look, the internet is filling up with AI-generated content, this slop, and scraping that inevitably poisons the training data for future models. They argue that access to clean, original human data is absolutely critical.
That's definitely one perspective, this sort of high-stakes warning. And it's a valid concern. But there is a counter-argument, maybe a glimmer of hope. Other researchers are suggesting, well, what if the synthetic data accumulates alongside a steady stream of new human-generated data?
Okay.
Which you could argue is maybe a more realistic picture than assuming all human data vanishes.
Ah.
In that scenario, they find the model collapse effect is much less severe, maybe even avoided.
Okay. But even if it's mitigated, doesn't that just feel like we're kicking the can down the road if the rate of synthetic content keeps exploding compared to human content?
That's the key question, isn't it? It really highlights the need for managing the data pipeline.
Right. So things like tracking where data comes from, data provenance, become crucial?
Absolutely critical. We need ways to filter out model-generated stuff, or at least know that it is model-generated. Things like watermarking or maybe AI detectors. If we want to keep training high-quality models, we have to be really proactive about the data we feed them. It's not optional.
Makes sense. Okay, before we wrap up, just a quick word from our sponsor. Today's deep dive was sponsored by embersilk.com. Embersilk is the answer for all your AI education and integration needs. Check them out at embersilk.com. So, as we finish this look at model collapse, here's something to think about, building on what we've discussed. Consider the early large language models. the ones trained before the internet got flooded with AI content. They arguably have this huge first mover advantage because they ingested so much original human text.
That's a very interesting point.
And the big long-term challenge for all of us, really, for society, is how are we going to navigate this? How do we distinguish human creativity and knowledge from synthetic replications online? Especially if we need that human foundation to keep learning, keep innovating.
It's a profound question,
Hmm.
a challenge that definitely requires our immediate and ongoing attention.
Absolutely. Well, to keep exploring topics like this, please do subscribe to The Deep Dive. And if you found this useful, maybe leave us a 5-star review. It genuinely helps us reach more curious minds. Thanks for joining us, and we'll catch you on the next Deep Dive.